I'll now go on and introduce our last speaker for the track. So Polly Hudson is a senior research fellow at the Alan and Turing Institute and the project leader for the Coloring Cities research program. She was previously a senior research fellow at the Center for Advanced Spatial Analysis, University College London, where she developed the Coloring Cities concept. She has also been the visiting fellow at the Kellogg Center for the Historic Environment, University of Oxford. Polly was trained as an architectural historian and worked initially in historic building restoration, museum, exhibition design, and community planning. In 1996, she set up the Building Exploratory Charitable Trust in London as a prototype for creative multidisciplinary knowledge-sharing centers about building stocks, where the first iteration of Coloring London was built and tested. So today, Polly is going to talk to us, or she's going to describe how the global network of Coloring Cities platform is currently being developed by a consortium of academic institutions. So please join me in welcoming Polly.
Can you hear me okay? Is it possible to have the lights down? The lights down. Yeah, that'd be great. We all live in buildings. If we don't live in buildings, it's an issue in itself. We work in buildings. We need to visit them for our health, for our education. And in this room, there'll be many experts on buildings, but there'll also be people who don't think they're experts, but actually are, because they're residents. And we walk in streets, and we know about buildings. And this project is about developing our collective, creating open tools that develop our collective knowledge about buildings, and use that to generate large-scale databases, which can be used in turn to generate knowledge. So why do we need open data on our building stocks? So, as I said, building quality, as we know, is critical and impacts on every citizen's life. The structural capabilities of stocks have been talked about extensively today. You know, how resilient are specific building types, construction systems to floods, drought, earthquakes, etc. We also need data on energy performance and the capacity for adaptation over time. Stocks are responsible for over 40% of global emissions. And we have to remember that that's not just about kind of heat emissions from buildings, it's also about churn within stocks, demolition, construction, and extraction of materials at source. So the visualization of spatial temporal data is also critical, and I'll talk about this in a second a bit more, for understanding underlying rules of operation of stocks and looking at them as dynamic systems. So what we need to get is large-scale, accessible databases to generate high-quality, efficient, sustainable, and resilient stocks. And we need spatial data that's visualized, and we need it at cell level. You know, from the 17th century, the development of microscopy can show you how technology walked hand in hand with the solution in terms of treatment of disease and understanding of disease. From the 1980s, GIS became very popular, and technology has begun to show us how we can start to analyze stocks at the micro scale. And with AI, satellite imagery, AI and machine learning, we're moving into a whole nother stage. And on the right, I just put some images of cells from looking at the city, the buildings as cells, and obviously biological cells, but also in the bottom right-hand corner, forgive the blurring visualization, this is an image of Charles Booth's poverty map of London from the 1890s. And what you can see there is that they're clusters of dark-colored spots in it. And what those were so it was assessed street by street at block and coloured at block level. And what was shown by this was that the highest levels of deprivation are the darkest colours. There were two studies done in the last 5 or 6 years, one by Dorling at Oxford and one by Noble at Queen Mary's Hospital. And Dorling concluded that there had been virtually no change in the position of deprivation in London in over 100 years. These are also the areas with the highest levels of type 2 diabetes. So 100 years of housing, social of housing and health policies have done absolutely nothing to alter the relative position of deprivation, which I think is quite shocking. And that's why we desperately need to have information on infrastructure itself. So the key thing that we're trying to do is create free tools that allow us to share our knowledge within countries, across communities, and across countries as well. So what are the main problems we've got with building stock data? The first is it's highly fragmented in many countries. It's held across multiple sectors, so that's academia, government, industry, third sector, and communities. It's held by multiple disciplines and professions and government departments, so this could be housing or planning, heritage, architecture, the property industry, economic property tax data, health, etc. So there's this lack of comprehensive spatial data at building level. And a lot in many countries, data are restricted, they're charged for, there are data gaps, and this is a key thing about visualization of data, is that it's very easy to spot gaps as well. And one of the real problems is that data on building characteristics, on performance and quality, and on dynamic behavior are not integrated. And we feel that these three elements, it's critical that these three elements are integrated, and that's what our system sets out to do. Also, it's extremely difficult to compare stocks across countries. You know, it's absolutely essential that we start working at a global level on understanding understanding in terms of what's happening in Lebanon and learning from that in terms of resilience, and comparing that with the experiences of scientists and people working in the humanities in other areas. So what is the Colouring Cities Research Programme? It's an open knowledge initiative which is run by the Alan Turing Institute. So we're the UK's National Institute for Data Science and AI. All our code, all our data, our open manual are all released under open licenses. We produce open source code for inclusive, networked, research-led open data platforms. And the critical thing about these is that they're managed by academic institutions. So one of the things about data governance is it has to be trusted. And we feel that was the most important thing, was setting up a trusted framework. So our code can be used by anybody. They're available on GitHub. But actually, we have a strong ethical framework and protocols that the academic institutions that work with us follow. So we work in Colombia, Indonesia, in Lebanon, which I'll talk about in a second, in Australia, Germany, Greece, Sweden, and Bahrain at the moment, but also looking at 5 or 6 more countries that are interested that we hope to work with this year. So we're trying to drive the production of standardized spatial attribute data sets that can be, this could be height data, it could be age data, it could be, any attribute. So we're looking at 128 at the moment that we're comparing across countries, but also these platforms allow for data at local level, regional, national level that's specific to the country to also be captured, and for open code to be written by the academic teams running the national platforms themselves. So the prototype actually was developed from 2014, for London, went live in 2016, and moved to Turing in 2020. And we started working with Sarah in 2018, I believe, to look at the involvement of Lebanon. You can see our wonderful Colombian Bogota team on the bottom right, and that's involving a lot of students, engineering students, in writing the code. So all you need to do to join the network is to be an academic institution. You can use our open code and join it to open footprints. This has been very complicated for many countries until actually the last year or so, when Microsoft Bing project has been generating open footprints which are now even available for Europe. And so that means that you can join our code to the footprints, and the footprints act as mini filing tablets that allow you to upload and visualize and share the data and to capture your local stakeholder knowledge. So as you can see from the image, you start off with the colored puzzle pieces, you put them through our system, and then you begin to structure it in a way where you can begin to see what's missing, what needs updating, and to look at the whole verification process. To make things simple, we have 12 data categories you can see in the bottom left-hand corner. So as I said, it's all location-based. So location data, land use, typology, the size and form and the construction system, the age and history, i.e. the lifespan of the buildings, all buildings previously on that site, which we collect, the bigger infrastructure context at street level, the team, so the developer, we capture data on the developer because we think that developers should be tracked over time, their performance, which isn't being done at the moment. Planning controls, we live stream planning data into the system as well. Energy performance, obviously critical. Resilience, I'll talk about in a second. And community, which is what actually people think about how well these buildings work. So just this diagram just shows you the key stakeholders. So we've got citizens, academia, government, third sector, and industry. And then the 4 data capture methods. So bulk upload of just what's there at the moment. In somewhere like the UK, there's virtually nothing available at building level. It's all controlled by government and not released. Crowdsourcing, computational approaches, and streaming of official data. And one critical thing is feedback loops between these. The way the data, the categories of data have been selected has been through an extensive analysis of papers, sustainability science papers and urban science papers to see what people are actually kind of needing, and also obviously working with people who work within sectors such as planning and housing. And those are growing all the time, the numbers that are coming back to us. So as you can see, they go through so that we start to collect information on physical characteristics, performance, as I said, and quality, and dynamic behavior, and these can be used by housing, energy, disaster management, etc. And that can be in planning simulations, in analysis, in 3D rule-based models, or whatever. So this is a very low-cost model. As Sarah knows, you can set it up with a single academic and some coding help. Use our code if you've got the footprints and start experimenting and demoing. And at the moment, Turing has been developing the prototype code, but we're now changing the system because the whole point is for us to begin to work to co-develop the code across countries, and that's really critical. So we now have a core repository, and we can all the academic institutions can co-work on that. And we're also developing global regional hubs to make it easier for academic institutions to collaborate. Within the countries themselves, in Australia and the UK, we're testing an academic network which allows different academic institutions within the country then to, as part of their research, to start gathering information at regional level. And then that can feed back into the national model, because you can't have one institution in the country trying to engage stakeholders at country level. You've got to break it up a bit further. So just to give you a few visualizations of Colouring Sydney. So data capture methods, the open bulk uploads. This varies massively. So USA and Netherlands have fantastic open data sets on the release of property tax data. Sets are the richest of any we've found. You know, they'll give you huge amounts of information on the characteristics, but they won't give you information on performance and dynamic behavior. And as I said, the release of these footprints by Microsoft Bing has been absolutely critical for allowing this to be reproduced more easily. But the thing is that bulk uploads need moderation. You can't just allow anybody to chuck up bulk uploads. So the idea is that the university networks moderate these large-scale data sets. Streaming from official sources, so this is planning data in the UK. This is the first time it's visualized at planning status level. So it's not just point data, it's linked to the building itself, but it actually tells you the status. So has it been approved? Has it been rejected? Why are certain things being rejected? Why are certain things being rebuilt over and over again in certain locations? So, and also this also allows residents, particularly, to comment on where they think development is going to occur. And that hasn't been possible before. And we thought that developers would hate that, actually. We thought because in the UK, for example, it's very secret what happens in the planning system. And people don't want the communities to complain about things. But actually what we found was this map that allows you to colour where you think buildings are, the developers love, because they said, now we know where all the other developers are working, which is really interesting for us. So it was kind of, yeah, it's a learning process. The last two, crowdsourcing. So I'm just showing you, you see Tower Hamlets here. This is home to 300,000 residents in London, and one single user added data for every single building in that borough. And I've randomly checked that data, and it's very high-quality age data, and it's done clearly by an architectural historian that has a group where they've shared the password, and it's become quite addictive because they've just been colouring in the things and filling in the gaps. This is also an arts project and a humanities project. It's also about the beauty of maps and the importance of colour in bringing us together as communities. And it's about joining science and technologies with science and the arts. Accuracy, a question that obviously we're asked all the time. I think the most important thing is that we have an accuracy statement, quality statement, and the key thing about this is it depends, and it's been brought up before earlier today, it depends what you're using the data for. You know, if you're using our data for a school project, and if you're using it for a policy, and if you're using it for an academic paper, you're going to need to check it in different ways. Our job is to provide as many ways to try and verify the data as possible and to show you the sources of it. That's what our job is. It's not to tell you that this is correct. And it's very important also, we think as societies, that we take responsibility. We don't just kind of listen to what somebody says about data being good or bad or whatever. We take responsibility that we have assessed it ourselves. So we use OpenStreetMap. Obviously, they use visible last edit date, which is very helpful to know the last, how recent it is. Source information, a verification button, so you can see how many people have also agree with it. But we're also going to be using icons that tell you what kind of data capture method was used, as well as this critical thing of feedback loops between these different data capture methods. So for example, throwing out, sorry, on this one, so this thing about computational methods, this is very important. What computational methods allow you to do, whether it's computer vision or inference, inference of roof shape because you've got building age and footprint, whatever, is it allows for large-scale data sets to be rapidly released. And then, through our system, they can be then checked by experts within the crowd. And so you get this feedback loop between what's gone there as it were as a draft data set, and then this checking process. Spatiotemporal data we see as absolutely critical. On the left-hand side, you have images from Hashimoto and Tanikawa 4D GIS, which are just wonderful, I think. What they show is the change in Nagoya city center from 1970 to 2009, and you can see in the upper slide the predominance of steel and wood to the rear, and then you can see how that's overtaken by reinforced concrete by 2009. Now, that's not only telling you about the kind of change to the material composition of the city, which obviously in earthquake analysis or all those things is kind of very important, but it's telling you about energy and waste flows that are occurring and the scale of them in that time period, and also about the displacement of communities. Stocks are very slow-moving systems, and therefore you need to go back a long way in order to understand the patterns and cycles, as we saw with the Booth poverty map, and historians are the best people to work with you on this. You can see on the bottom right we have survival maps, so this is using historical maps and allowing people to click on the current footprint in relation to the earlier map to see what percentage of cities has survived over certain periods of time, which I think to many communities are very shocking when they actually realize how much demolition and wastage is occurring at a time when we actually need to be doing the opposite. I'm not quite sure whether these are going to animate. Oh, yes. So this is 100 years of constructions and demolitions in Zurich. This was done by Axos and Hassler and Kersler. And it's the most comprehensive and detailed information on lifespan animation that I've seen. I'll just click on that one. Thought we had a bit of music. This is 250 years. We did an area of London. We animated every single building that had been constructed and demolished during this time. And one of the things is just to show that it's you know, using visuals is a very important way to engage people on lots of different levels. There are lots of ways of analysing the stocks, but we mustn't forget those who actually have a lot to say but need different kinds of tools to do that. On my just last couple of slides, so in terms of the disaster mapping feature, we actually saw earlier with Beirut recovery map. So this was actually involved, I met Sarah Najem from American University of Beirut in 2018 at a conference. And Sarah immediately just said, oh yeah, we'll just try and use your code, and we'll just set up Colouring Beirut. And I went, really? And then she went, yeah. And it was proof of concept for us. It was the first time that our code had been used internationally, and that allowed us to then move on and start expanding. So we're extremely grateful to the university for that and to Sarah for her work. When the terrible blast happened in 2020, we got together with Melda Salhab, who was then working on a project with colleagues for OpenMap Lebanon. And what happened was that the work done on Colouring Beirut was sort of absorbed into that project. What you see at the top on in the middle is the bomb-damaged map of London from the 1940s. So every single building in London that was bombed was coloured according to how much bomb damage had occurred. So then we used this approach, and we had a discussion with SARAID and AUB, us, and OpenMap Lebanon. And some really interesting things kind of came out of it. One was the fact that you could color code this and see what the severity was, but people would want to know, you know, how is that data collected? And so we thought, we said to SARAID, well, we could put SARAID, or we could put, the NGO that collected the data, or whatever it might be. But then all these issues of liability came up. And this is a kind of really important thing as well. You know, you want the source. And in the previous talk about privacy of data, there are all these other issues that we need to think about. We need to balance the science, and we need to balance that with actually us as people and our privacy and the very scary things that can potentially happen with AI and what we're walking into now. And we need to be very mindful for that in all the decisions we make. Actually, from the previous talk, I was thinking that the satellite imagery and discussion of AI and satellite imagery for earthquakes, for example, could actually be, you could rapidly absorb that in and then ask the community to check that. Because you can see on the bottom left side, in our sample, which we're integrating into our code, you can choose from what kind of disaster it is and then the level of severity. So just finally, just some applications. So we're working with computer vision on the classification of building typologies at the moment at Turing. The Colouring Australia platform has been integrated into the Australian Housing Data Analytics platform, and so it's an integral part of that. In the middle, you see this is a commercial planning model where they've streamed our age data for London into, and on the left-hand side, work with Flora and Pani on 3D procedural models, so rule-based models that allow our open data to be used to create dynamic simulations. I'm just going to end with some of the fantastic women that I have worked with, and very much hope that in this room there are women who might want to collaborate with us in the future. Thank you so much.
Thank you, Polly. I guess one question with 1 minute question and response, so please.
Can you hear me?
Yeah.
First of all, thank you for your presentation. It was me thinking of the future. Can this be integrated with Google Maps in a way where you can check where there is a missing gap and color it maybe, or see what has been colored and check on the map while you're walking, like this building is aged how much, and
so all the data produced by all the countries we work with is that it's open. everything's open. So if Google want to integrate it into their systems, or anybody want to, and it has third-party use as well in the license, so any commercial company can experiment and innovate with it. That's what we'd like to see, definitely. We don't do the other way around. We wouldn't approach Google or a commercial company and ask them to connect. And the reason for that is that, well, there are a number of reasons for that, but one of the main ones is that, for example, Google permitted use of its Street View images for analysis. And I have a colleague at Turing, who's also at UCL, who was working on for many years using those images, and suddenly they decided to restrict access and to prevent use. And we can't afford for that to happen. You know, so of course we want to work with commercial companies, but we need to make absolutely sure that in our network and in our system that these data are available and open for everybody, and that there's no possibility of restricting them in future.
Thank you.